Welcome to the Professor's DuBois channel. This is Professor Corey, and this video is a mini lecture based on our 5th lecture covering material from Chapter 3. Disclaimer, this is in no way equivalent to our actual lecture where we discuss and practice the material in much more detail. We begin this lecture with an analogy. The question is, how many sandwiches can you make if you have 28 slices of bread and 9 slices of cheese? We can only make 9 because this uses all of our cheese. Cheese is the limiting reactant in this scenario. We can even determine how many slices of bread remain by calculating how much bread was used by 9 slices of cheese. 18 slices of bread were used, so 10 slices remain. We will apply this concept to chemical reactions in the subsequent slides. In our sandwich analogy, we had an excess of bread and the theoretical yield was 9 sandwiches. Cheese was the limiting reactant, and we had to consider how many sandwiches could be made with both the bread and the cheese to determine which was the limiting reaction. You may predict that nitrogen is limiting this reaction because there are fewer moles. However, we cannot accurately predict which is limiting without considering the mole-mole ratio of the reaction. Try for yourself. You will do 2 calculations. The first will start with 10 moles of nitrogen over 1. Use the balanced equation as a factor to calculate how much ammonia can be made. The factor is 2 moles of ammonia over 1 mole of nitrogen. So the result is 20 moles of ammonia. That can be made with 10 moles of nitrogen. Do the same calculation with hydrogen. Whichever produces the smallest amount is the limiting reactant. If you're feeling adventurous, pause the video and try this. I will explain the calculation in the next slide. This time, you first need to convert grams to moles before using reaction stoichiometry to solve the problem. When comparing the amounts predicted by both reactants, the smaller amount will be the correct result. You can check your work if you tried the problem. If not, follow along and try the next one. We start with 750.0 grams of each reactant and use the molar mass to convert to moles. The next conversion is the mole-mole relationship of reactant to product, so the 4's come from the balanced equation. This reaction will only produce 18.75 moles of nitrogen monoxide. At this point, the oxygen is gone and the reaction ceases. Using the molar mass of nitrogen monoxide, we can calculate the theoretical yield in grams. Remember how we calculated the excess bread in our sandwich example? Now we will apply this to the chemical reaction. Start with the limiting reactant and calculate how much of the other reactant was used. Use the molar mass to get the moles of oxygen, then the balanced equation for the mole-mole relationship between oxygen and ammonia. Molar mass of ammonia will give our result in grams. We used 319.3 grams out of the starting amount of 750.0 grams. In industry, you would look for opportunities to save production cost by assuring that there is not a large excess of any reactant during a chemical reaction. There are 2 yields to consider during chemical reaction. There is the theoretical yield that you calculate using reaction stoichiometry. In the lab, it is common to have losses of product during the reaction process. For this reason, our actual yield is expected to be lower than our theoretical yield. We can express this as a percent by dividing our actual yield by the theoretical yield and multiplying by 100. The higher the number, the more efficient our process is. This is an example. Exam problems rarely state actual yield, so you have to be able to identify this from the information given. Just remember, theoretical yield is pen and paper. 501 grams recovered in the experiment is our actual in this case. This question encompasses all of the material covered. You will have to balance the equation first before moving on. Pause the video and give this a try, and I will provide the answers on the next slide. A little practice goes a long way, so practice a lot and make sure that you can solve this type of problem independently before the next exam. Thanks for watching. Please give this video a thumbs up and subscribe if you would like to see more mini lectures on the Professor's DuBois channel.